Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about VSEPR theory. VSEPR stands for valence shell electron pair repulsion. It's a model used to predict the geometry of molecules based on the number of electron pairs surrounding a central atom. VSEPR theory assumes that electron pairs in the central atom's valence shell will arrange to minimize electrostatic repulsions between them. This is achieved by maximizing the distance between electron pairs. In other words, the negative charges of electron pairs repel each other so that they are spaced as far from each other as possible. Remember that a central atom's valence shell electrons are located as lone pairs or as bonding electron pairs with other atoms. Let's start with hydrogen gas. Consider one hydrogen atom as a central atom with another hydrogen atom bonded to it. This molecule forms a linear shape. The atoms are in a line. What if there were two atoms bonded to the central atom? In beryllium chloride, beryllium is the central atom connected to two chlorine atoms. Recall that in VSEPR theory, the electron pairs in the single bonds repel each other and want to be as far from one another as possible. This means the atoms will arrange themselves in a line, giving beryllium chloride a linear geometry. Its bond angle is 180 degrees. Beryllium chloride only has single bonds. What about molecules with double or triple bonds? How does that influence molecular geometry? Let's look at carbon dioxide, which has a central carbon atom with two oxygen atoms connected by double bonds. Although carbon has 1, 2, 3, 4 electron pairs, there are only two places, 1, 2, where the electrons can be found. A molecule's geometry is indicated by the number of locations of electrons in a valence shell, not by the number of pairs of valence electrons. Therefore, VSEPR theory suggests that electron repulsion is least when the double bonds are at opposite sides of the carbon. This forms a linear molecule with a bond angle of 180 degrees. Let's consider hydrogen cyanide. There is a central carbon atom with hydrogen attached by a single bond, and nitrogen connected by a triple bond. Remember that molecular geometry is influenced by the number of locations of electrons in a valence shell, not by the number of pairs of valence electrons. Carbon has 1, 2, 3, 4 electron pairs, but there are only 1, 2 places where the electrons can be found. VSEPR theory predicts that the single bond and the triple bond will arrange to be on opposite sides of the carbon atom to minimize repulsions, thereby forming a linear geometry with a bond angle of 180 degrees. VSEPR theory is a useful model for predicting an individual molecule's geometry based on the number of electron pairs surrounding a central atom. The valence shell electron pairs assume arrangements that minimize electrostatic repulsion by maximizing their distance. With only one or two atoms on a central atom, VSEPR theory suggests that the molecule will have a linear geometry with a bond angle of 180 degrees. Thanks for watching ChemDoodle Shorts.